Hello, so I'm doing my presentation on on the article called Advanced Aging Enhances the Positivity Effect in Memory Due to Cognitive Control or Age-Related Decline in Emotional Processing. So my first slide, I talked about the hypothesis and the topic. So the topic is the positivity effect and how it varies between ages. It's important just so that we, understand the changes as we grow up. It's very different as it would be from a young person to an old person, just in terms of like wisdom, in terms of life experience, memories, psychological decline, diseases, all that kind of stuff. It can also lead to helping people enhance their memory as they do get older so that they're able to recall better memories and stuff like that. It is insightful into emotional health and how older individuals do have a tendency to recall more positive experiences. It shows that they have an overall happier outlook on their life. So, into the hypothesis, also sorry that the topic's kind of skewed. I couldn't see that until I started recording. But the hypothesis into that of this experiment is that they assumed that there would be a decrease in the sorry if I butcher this, the amygdala's reaction to negative stimuli in older people, but not a change in positive stimuli. So basically, they would still be um, getting the positive stimulus from memories, but then as they got older, their reaction to negative memories and negative stimuluses, which we'll explore as a shock factor, decrease. And then their second hypothesis, because there was a couple different experiments and like theories that they had, was that there would be a positive correlation between the positivity effect in memory and attention and age. So those were the two hypotheses that I found in this article. So moving on to the next slide. So just talking about some of the independent variables took me so long to figure this out because for some reason my brain cannot figure out what the difference is between independent and dependent variables, even though I'm literally 20 years old. But moving on, so in one of the sessions they found like they were testing they had the frame of the IAP images, the time between the sessions, so it would just vary. They would usually show like a blank screen, or in the session 2, they showed the jittered fixation cross time. And then there was differences in font color. So when they were showing the IAP and the stuff like that, they would basically change it from like like a red font, and then sometimes they would say, like red and it would be red, but other times it would be red and the color of the font would be blue. They also filled out a questionnaire before they started. Obviously, their ages and their sex really pertain to this. Not as much the sex, but the ages. They were all from the same university, which I thought was very interesting. Things that I didn't include was that they also had a lot of standards, like they couldn't have any hearing issues, couldn't have any seeing issues, cognitive issues, how to speak fluent English, and then they signed their consent form. And in the session 2, they would change their, I don't know why I included this, but change in pitch, the jittered fixation cross time, so they would, show it for 6, 8, or 10 seconds between, and then no one knew what the shock probability was. So for the dependent variables, participants' responses in the free recall test, the Wechsler test of adult reading, the response to pain, because there was an experiment based on them not knowing if they were going to get shocked or not, which was going back to the amygdala being able to associate the negative stimuli. The ability to recall and describe images. They would basically be given, I think it was 60 images, and they would have to recall them after doing like a Sudoku game or something like that, and just testing if they were able to recall it. There was a response time to the stroke task, so I'm pretty sure that was the one where the font didn't match the color. And then their perception of time and life, so just the ages that really varied and how it overall changed the way that they reacted to these tests. So, how the researchers conducted the study. So, number one, they did a free recall test. So, participants were asked to remember and count details from a list or something else. The Wechsler test, the participants had to read a passage, they answered their questions, they did a comprehension and thinking skills kind of thing, and then that was obviously recorded. They had a pain response, so the participants rated the pain level after the controlled stimulus. So basically, they wanted to make sure that the shock wasn't too crazy, so they had them test the shock beforehand, stuff like that, or like, whatever pain level they had. The image recall, the participants were shown the pictures, then they asked to remember them and describe as much as they could about them later. The Stroop test, the participants did a task where they had to identify the color of a word, not what the word says, and their speed was recorded. So, like I said, basically people were shown red, but the color of the font was blue, and they had to say red as fast as they could. And a lot of times they found, that sometimes it would mess them up. And then the perception of time, the participants were asked about their feelings regarding the remaining time of their lives. So obviously it would be different if you're like me and you're 20, and if you're 60, there's going to be a very large gap between the remaining time in life. I know that, death is unexpected, but in terms of like, dying of old age. The researchers then compared those results of all of the tasks between all the different age groups to examine how this affected the positivity effect. Next slide. So the results that were found were that younger adults could recall more images than older adults in the free recall task. And then second finding, when considering, age differences in memory and comparing, different stuff like that. I don't think that there was a huge difference in that, but there was a significant main effect of the valence, so the negative, positive, neutral of like the different shock factors, um, and stuff like that. The older adults recalled fewer negative images than the younger adults, and there was not a significant difference between the groups recalling the positive images, which I think is really interesting considering I feel like that's kind of what they were measuring. But I think a big part, as I'm going to discuss, is that they were disproving some of the other theories. So on my last slide, I said, was this replicated before? So this experiment was based on a lot of other studies that were referenced, which is what I will include when I send this, the article and all. But they did find that parts of it didn't correlate with how they thought it was. These parts that they didn't necessarily see agree was that they found a positive correlation between memory and age, like memory positivity and age, and then older people with a good and like secure amygdala learned fear and went against the aging brain model, which I thought was really interesting because basically in my first slide, when they were talking about their hypothesis, they were saying that if it went with age, the amygdala would not be so good, so they would not have a good reaction to negative stimuli, which would be fear, which would go into the shock factor. And they actually found that it went against a lot of the other experiments. And then not only is the positivity effect determined by the time perspective, but also by preserved cognitive control mechanisms underlying emotional regulation. So basically, it's not only affected by how old you are and how you see your life and time and death, but it's also comes down to just how smart you are, because they did measure a lot of the IQ and how much control you have over your emotion, your mechanisms, and just your overall cognitive ability. So that was my article. Hopefully, it doesn't look too bad, but thanks for listening.